about functions. We should remember functions from Algebra 1. So let's go back over the basics so we're talking in the same language. A relation is just a set of ordered pairs. Be it a set of listed out ordered pairs, x, y, x, y, x, y, or a table, or points on a graph. Even graphs can be relations because it's an x and a y. It's a pairing of ordered pairs. The pairing of height and weight. We're pairing two things. That's all a relation is. Now, special relations become functions. And what a function is a relation where each input is paired with only one output. So like my example of height and weight. Does everybody who is the same height, 5'6", do they all weigh the same amount? No. So that relation is not a function. Now, what is the domain of a function? Well, that is the set of all input values, or x's. In a lot of cases, we use x to talk about inputs. And the range is the set of all output values, our y's. So each of these that's listed below are relations. They have a pairing of x's and y's, inputs, outputs. So we need to check and see if these relations are functions. So let's look through the first one. Each input can only be paired with one output. So here I have 1 paired with a 3, and then 1 paired with a 6. That is not a function. And I'm just noticing that my second example is exactly these same points, but visually. 1 is going to 3, 1 is going to 6. That's what makes it not a function. Also, 3 is going to 9 and 3 is going to 12. That is not a function. Now, we also could have graphs that are functions, or they can just be relations. So what I have to think about is for each x value, am I only getting out one y value? So y equals 4x minus 3. If I plug in a value for x, I'm going to get a single y value. This is a function. But notice on the next one, y squared equals 2x. Let me go into this one in a little bit more detail. So y squared equals 2x. If I plug in an x value, I'm just going to plug in 8. I get y squared equals 2 times 8, that's 16. What squared equals 16? Well, that is 4 and negative 4. So for one x value, I'm getting 2 y values. That is not a function. One way I can tell is if y is singular, in other words, it's only one on the exponent, or if y is squared, or absolute value of y, or something like that. Now, what we can do with functions is we can graph them. And just a reminder, the easiest way to graph a graph is to make a table, and you can always do that. Whether or not you've got a calculator or not, you can always make a table. And I'll pick like 5 x values. And if I plug in -2, -2 squared is 4. 4 times 3 is 12. -1 squared becomes +1 times 3 is 3. 0, 0 squared is 0. 0 times 3 is 0. When I plug in a +1, I get 3, and then I get 12. So I end up with this graph. I'm going to go up a little bit. -1 goes to 3, 0, 0, 1, 3, 2, 12. And if we remember our Algebra 1 and our Algebra 2, this is a nice parabola. Now, one way we can tell if we were given a graph that this is a function is something called the vertical line test. To pass the vertical line test, no vertical line may intersect the graph at more than one point. So if we look at this graph here, if I drew vertical lines, I'm only hitting the graph at one point. That makes it a function. Now, other things we do with functions, we evaluate functions. We find f of something. So this f of x notation means the function's name is f, and the input is x. So when you're given the formula, they're telling you that the variable they're using to represent the input is x in this example, f of x. Now when they give you an actual number, that just means I'm going to replace that input with a specific input value, in this case of 3. So it'd be 2 times 3 cubed minus 3 times 3 squared plus 1. And I'm going to go ahead and do that. Well, I'll do it in hand. That's 2 times 27 minus 3 times 9 plus 1. That's 54 minus 27. 54 minus 27 is 27 plus 1 is 28. So I'm given an input value. I will get out a output. In other words, the y value that goes with that x. F of -1. -1 cubed is still going to be -1. -1 squared, though, is going to become a +1. So I've got -2, a -3, that's up to -5, plus 1, that's a -4. Now notice the difference here. This is saying not replace x with a specific x value, but replace it with this expression of -a. -a cubed would be -a cubed. So that would end up giving me -2a cubed. -a squared would become a +a squared. And notice we have a new function. So when we replace x with an input value, we get an output value. If you replace it with a new expression, you get out a new expression. Okay, so a lot of times we'll be representing a real-life situation with a function. This is a function. The number of personal income tax returns filed electronically. I don't know why it has T there and we have W there. I think I looked at two different things. because, that should be a T. All right. We'll change it to a T. Where X is the number of years after 1995. So W of T of 30 would mean we're going to plug 30 in for X. .94 times 30 plus 26.4. We get 144.6. So notice right there, it just asks us to find T of 30. But what does this mean? Well, this means the number of personal income tax returns filed electronically. I cannot spell. Electronically is 144.6 million when X is 30. But what does that mean? Well, X is the number of years after 1995. So if I add 30 to that, I get the year 2025. So we're making a prediction using that function. The next one. The table to the right shows the approximate number of years it will take a couple to pay off a $100,000 mortgage at several different interest rates if they pay $800 per month. R denotes the rate, and those are percentages, and F of R denotes the number of years. Okay, so what is F of 6.3? Well, let's look at the table. F of 6.3 means I'm going to look for this at 6.3, and I get a 17. And what does that mean? It means at 6.3% interest, it will take the couple 17 years to pay off the mortgage. F of R. If F of R is 20, what is R? So this time it's given us to us a little different. They gave us the output. What's the input? So I would look at the table. The F of R is 20. The input for that is 7.4. Does F of 2.4 plus 6.3 equal F of 2.4 plus F of 6.3? This is kind of an important note to make. So if I added those two inputs on the inside, I get 8.7, right? Well, what is F of 8.7? Well, that's 27. What is F of 2.4? Well, that's a 12. And F of 6.3 was 17. So do they equal each other? No. So adding the inputs together is not the same as adding the outputs together. All right. Now the next thing we're going to do is a special pattern called the difference quotient. And it's just simplifying is really all we're doing. Now I need to break this down into what I need to find to be able to plug in. It says to find f of x plus h minus f of x divided by h. Okay, so let's come off to the side and figure out what f of x plus h is. What that means to do is I'm given an expression. That expression will replace my variable. So that's going to go in where x is. And I think I would like to simplify that just a little bit. So x plus h squared means I'm going to take x plus h times x plus h. Here, I need to distribute a negative 3. So negative 3x minus 3h plus 8. So distribute. FOIL. X times x is x squared. X times h is xh. And then I'll have another h times x. I'm going to write that as xh. And then h times h is h squared. It's long, but it's doable. We have 2 of those, so 2xh plus h squared. So now let's come over and work on the difference quotient. So this is f of x plus h. So in my formula, f of x plus h is going to be this whole expression. It's a new expression. And I'm supposed to subtract f of x. Well, that's my original f of x. X squared plus minus 3x, it's a minus, plus 8, it's a minus. All divided by h. Well, I need to distribute that negative over there. I don't need anything in front of the parentheses here. When I distribute the negative, that's going to become negative x squared plus 3x minus 8, all over h. Ooh, I see some interesting things happening here. Got an x squared and a negative x squared. Got a negative 3x and a positive 3x. Positive 8 and a negative 8. Ooh, that's a lot of stuff. So now I've got 2xh plus h squared minus 3h, and everything else has gone away. And that's all being divided by h. Notice everything that's left has h's in it. So if they all have h's in it, I can divide each term by h. So the first one would be just a 2x. H squared divided by h is h. Then that would be a negative 3. So look, it got really ugly, but it simplifies nice and pretty. All right. I'm really feeling I should have done some of these in a different order, but we'll just go with it. Domain and range. Domain. What x values can I plug into here? Well, let's use our graph to help us. This is 4x squared. It's a nice parabola. And even though I only see x values, I'm going to change my window back to a standard so you can see it a little bit better. I can only really see x values from -2 to 2. If I look at my table, oh, my table's messed up. Let me get it back to normal. I can see that more x values give me answers. They're just out of my picture. So my domain is actually all real numbers. And you can do the fancy R, or you can write all real numbers. Now, when I look at the table or the graph and I'm looking at my y values, I notice the smallest one is 0. And everything is above that. So my range is y is greater than or equal to 0. Let's look at the next one. Okay, and I'm at the graph. Well, that's kind of interesting. Let's look at the table. Okay, so the negative numbers were fine. I saw that on the graph. But once I go past 4, it keeps giving me errors. And if I look back at the graph, I'll see that the horizontal, the x's, only go up to 4, but not past it. So on this one, my x's are less than or equal to 4. And that's because this radicand has to be positive. So I have to be able to plug in numbers that are smaller than 4 to make it positive. Now let's think about the range. Let's look back at the graph. Do we have anything down here? And do you think this keeps going up, 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 up? I think so too. All right, the next one. Now, if you have not worked with a graphing calculator much, if you press alpha y equals, you should get a fraction. If you don't, then your software needs to be updated. The graph. Ooh. This one splits, and it splits, it looks like at around 2. So if I look at the table, when x is 2, there's an error because there's an asymptote there. But all the other x's seem to be fine. So x cannot be 2, and that's because 2 minus 2 is 0, and I can't divide by 0. Now let's look at our graph and see about the y values. It looks like it didn't ask us to find the range. We'll do that later. Okay. It just said find the range for parts A and B. We're good. All right. A little bit more review. F plus G. That means to take f of x plus g of x. It literally means to take 3x plus 2 plus x squared minus 3. It literally means to add them. And so you would get x squared plus 3x minus 1. What do you think this means? It means to take f and subtract g. So this one, I would have to actually distribute that negative in the second parentheses and then combine my like terms. What's the dot mean? Well, that dot means we're going to multiply. That means I need to distribute. So 3x times x squared is 3x cubed. 3x times negative 3 is negative 9x. 2 times x squared is 2x squared. 2 times negative 3 is negative 6. And it is actually fine to leave your answer like that. I know it's not in order, but it is okay to leave it. Now, as far as dividing, we're not going to actually do the polynomial division here. We will just be setting it up as 3x plus 2 over x squared minus 3. But there's one thing I have to tell whoever's looking at my answers. I have to tell them that this is okay as long as x squared minus 3 never, ever, ever, ever equals 0. Then I'm all right. All right. Last bit on just basic function notation. And oh, I'm sorry, my marker just kind of bled through, so I'm going to have to zoom in a little bit. All right. This open dot, this means of. That's not Goff, and that's not fog. This literally means that we are going to be taking g of f of x. So I'm going to take f of x and put it inside of g. Literally replace the x in g with f of x. It's kind of like substitution. And we could simplify that. That would be 2x cubed plus 1 times 2x cubed plus 1. 2x cubed times 2x cubed would be 4x to the 6th. Outer would give me a 2x cubed. Inner would be another 2x cubed, so that would be 4x cubed. Remember, our exponents only change when we multiply. Then 1 times 1 is 1. Notice the difference here. F of g of x. This means I'm doing it in the other order. I'm going to put x squared in for x over here. Now, x squared cubed gives me x to the 6th plus 1. Now, this one I won't make you simplify, but I want you to think about what we're doing. F of x. This means I'm going to take f of x and I'm going to put it inside itself. Now, we're not going to simplify it, but that's the thought process on composite functions.